Okay, good morning. This is Professor David J. De Los Reyes. Okay, my topic for this session will be a not so long video format, but it's a long video format, and this will still be a topic on algebra. So my topic for this morning will be the solution of a quadratic equation by completing squares. Okay, let's proceed. I will try to read the problem. Find the value of x by using completing squares. Okay. So the given quadratic equation is 3x squared minus 4x minus 4 equal to 0. Actually, we could present three solutions here. If a given quadratic equation is solvable by using factoring, we could use factoring immediately. But the problem requires that we should bring out the solution of this by completing squares. Or the next solution will be by using the derived quadratic formula, the standard quadratic formula for quadratic equations. But the problem is not asking that we should use the quadratic formula. What the problem is asking is completing squares. So let's try to bring out the solution of this by using completing squares. I will try to read the given quadratic equation. That will be 3x squared minus 4x minus 4, and this should be equal to 0. And the problem is asking for what are the possible values of x. Actually, there will be two values of x. It's a quadratic equation. So there will be an x1, okay, and there will be an x2. Because it is quadratic, right? So it could either be a real number or what do you call this, a combination of a real and imaginary number, or that will be a complex number. Will it be a complex number, or will it just be simply a real number? Okay, let's try to bring out the solution. Solution. I will rewrite the given quadratic equation. Okay. Next step is to transpose all constant terms to the right. That will be the second step. So it will become a 3x squared minus 4x, and this should be equal to positive 4. This minus 4, if we place it on the right, it will now become a plus. Right? That will be the next step. The next step is to make the coefficient of x squared unity. Okay, a unity meaning it is 1. So we must have to eliminate this 3 here. So to eliminate this 3, for the coefficient of x squared to be unity, we will multiply all terms by 1/3. Right? So a 3x squared times 1/3, it will become x squared, because this 3 cancels with this. Right? So the resulting coefficient of x squared rather, it will now be unity of 1. Okay? Minus 4x times 1/3, it will become minus 4/3 times x. So the resulting coefficient of the x term now will be 4/3. Of course, it is negative. And this should be equal to, a 4 times 1/3 will be 4/3. Okay, that is actually the second step. The third step is this is now the hard part of the solution. If you do not know the formula and how to take or to make the left hand side a perfect square, okay, you've got a problem. But under algebra, to make the left hand side a perfect, what do you call this, a perfect square, okay, take 1/2 of the coefficient of b. So I will be writing this one. This is standard. Take 1/2 of the coefficient of b, okay? Then try to square that one. Okay, that is actually the general formula on how to make the left-hand side a perfect square. So what we did is, if we try to inspect the value of, or the coefficient of x, because under the quadratic equation, that is ax squared plus bx plus c equal to 0. This b here refers to this. So if we try to inspect the left-hand side, the coefficient of b is actually negative 4/3, right? If we try to follow this, so this should be 1/2 of the coefficient of b, which is negative 4/3, close bracket, square. It should be squared, right? So it will become negative 2/3 square. 4 and 2 cancel, so what remains here is 2, negative 2, right? Or it will be negative 2/3 all quantity square. Negative 2 square will be positive 4, and 3 square will be positive 9. So the square of 1/2 of the coefficient of b is actually 4/9. So the significance of this, meaning if we add 4/9 to the left-hand side, it will now be a perfect binomial, right? So next step will be to add this 4/9 for both the left and right. So this is x squared minus 4/3 x plus 4/9 equal to 4/3 plus 4/9. We add this one. Oh, that is one of the rules under the so-called properties of college algebra, fundamental operations. What you add on the left, it should be added also on the right. It will not change the equality of the given equation. Okay? So after adding 4/9 on the left-hand side, this is now factorable to x minus 2/3 quantity square. Okay? It is now a perfect binomial. And for the right-hand side, we got no problem. It's just a pure numbers, but we are adding two fractions with different denominator. So to add the right-hand side, we must have to make the denominator same for both the first and the second. So to do that, we will multiply 4/3 by 3/3 plus 4/9. Because 3/3 is 1, okay? It doesn't change the value of 4/3. So what will come out will be, if we try to multiply 3 by 3 here, the resulting denominator of the first one will be 9, and the second number on the right-hand side will also be 9. So we could add now, right? So it will be 4 times 3, which is 12, plus 4, all over the common denominator 9. So rewriting the left-hand side, and this should be equal to 12 plus 4 is 16 over 9. And 16 is a perfect square, 9 is a perfect square. So under one exponent, 16/9 can be written as 4/3 quantity square. Right? So to make the, okay, or to compute for the value of x, we must have to eliminate these two here on the left-hand side. So what we did is that take the square root of both the left and right. So meaning to say, x minus 2/3 quantity square equal to 4/3 quantity square, open bracket, close bracket, raised to the 1/2. So these two here cancel with this. And these two here cancel with this. Okay? And that's gone. So no more power 2, right? So what remains will be x minus 2/3, and they should be equal to. For the right-hand side, since 4/3 is positive, Okay? The square root will just be simply plus or minus 4/3. It should be plus and minus, right? Right? And to compute for x now will be negative or plus or minus 4/3. We transpose this to the right, it will be plus 2/3. So by using the positive side, the plus 4 here, x1 now will be positive 4/3 plus 2/3. Okay? This is 3 and 3, and we are adding two fractions with the same denominator, so it will be under same denominator 3 plus the sum of the numerator, which is 4 plus 2. 4 plus 2 is 6 divided by 3, so x1 will be 2. It's a real number, right? And for the value of x2, if we try to use the negative sign, it should be negative 4/3 plus 2/3. All same. This is 3 and 3. We could combine now. So the resulting numerator will be the sum of the numerator, which is minus 4 plus 2 all over 3. And this should be negative 2/3. So the value of x2 is actually negative 2/3. Okay? Okay, that's it guys. The solution of this given quadratic equation by completing squares. The key to the solution is by adding 1/2 of the coefficient of b, then try to square that one. If we try to add this one on the left hand side, it will now be a perfect binomial. Right? And for the right hand side, you just simplify it because it is just a pure constant. Okay, that's it guys. That's the solution of the quadratic equation by completing squares. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.